Hi, everyone. Welcome to London's Calling and welcome to my session. I would really like to thank all of you for joining my session on styling LWC the right way. My true appreciation, because styling for most developers is not the most interesting or important topic. But in case you don't style your components correctly, down the line, if you have any issues, you'll actually pull out your hair figuring out why that issue is happening. So it's important to understand how to style your components the proper way. And to tell that, I am Aditya, a lead developer evangelist at Salesforce. And I'll be your speaker today. So you can chat with me using the chat window. Any questions, feel free to put in. I'll be available all the time to help you answer any questions that you might have. And even after the session, if you want to get in touch with me, you can get in touch on my Twitter handle, which is also on the slide. With that, let's get started. And as you know, you've seen the statement a lot too many times. The forward-looking statement, which basically says, please make all your purchasing decisions based on generally available information and not based on what I might say today. Though most of it is generally available except for a few features that are in beta, but you should be good there. But in any case, the forward-looking statement. So today, what we're going to do is we are going to learn a little bit about Shadow DOM, and then look at what style cascading is and how it differs from inheritance and why knowing about the difference between both of them is important. And then you're going to learn about scoped and unscoped styles. Again, you might not really know the concept behind this, but you might be seeing its output and wondering why that is happening. So you'll get a clarity about that. And finally, we are going to look at CSS custom properties. So this is my favorite picture from my favorite cartoon show. And yeah, this happens in case you don't write CSS properly. So getting started with what Shadow DOM is. I'm sure if you're working on Lightning Web Components, you would have already heard about this, that Lightning Web Components is built using all the latest web standards. And out of those, two important standards are custom elements and Shadow DOM. And for example, if you look at the screen, I have a simple web component here that says my simple example. And then this is the HTML file for that. And I have my HTML code inside the template tag. Now when it is rendered, if you see, we are creating a custom element. So this HTML tag is the custom element that gets created. And what we also do inside the custom element is create what is called a shadow root. And then whatever is the content of your template gets added into the shadow root. So this is the shadow root, and whatever are the elements that are present inside your shadow root are known as Shadow DOM. So those are the two things that you need to know. And one question you might get is, why Shadow DOM? And the reason for that is Shadow DOM provides encapsulation. And encapsulation is provided in 3 layers. First is the markup. So whatever are the elements that are placed inside your Shadow DOM, they can't be accessed using traditional methods. So let's say you've built a component and somebody else is using your component in a page. And in the page, they write a bunch of scripts and they're trying to access all the elements in the page, trying to modify them. What happens is all the markup elements, all the Shadow DOM elements are not returned to the parent page because of this encapsulation. That way, your component is safe. Nobody can manipulate your component from outside your component. Next is behavior. So any custom events that you define, I'm sure when building web components, you would have defined a lot of custom events. And typically by default, bubbles is false and composed is false, that you know. Now, all those events do not escape the shadow boundary. So any events that you create inside your component or its hierarchy, stay inside the shadow boundary itself. But if you want them to cross the shadow boundary, it is in your control as a developer by saying you have to explicitly set bubbles to true and compose to true. Only then your events escape shadow boundary. So you're getting a bit of control. And finally, the reason we are here today, CSS. And the CSS defined in the parent component don't affect the CSS styles in your child component. That is what is a generic statement that all of us are going with. But is it really happening that way? Let's actually take a look and see. Now, this was a very brief introduction about Shadow DOM, but if you're interested to get a bigger picture, a longer session on that, watch the developer quick take by Alba, one of my colleagues, in which he's explained everything about Shadow DOM. It's a quick take, about 6 to 10 minutes, not much of your time, but do take a look. Now, the reason I've mentioned about Shadow DOM is Lightning Web Components uses Shadow DOM, and that is going to affect the styles. And let's see how that happens. So I've told you that we never know what styles leak into a parent component to a child component. So let's actually look at a demo for that. So here you need to understand two concepts. So first is cascading, and the second one is inheritance. All of us use the word CSS a lot, which actually stands for cascading style sheets. So cascading is an inherent part of CSS. So let's look at this example. Here I have built a Lightning Web component with several cases. I'm going to walk you through each one of them. So first I have a div with some simple text. And in order to style this div, I've created some style classes. Here I have some color, which is a class. Then I've selected the div element. And then here I've defined background green, padding, and then I've redefined div, and I'm defining the background to be a different color. Now, what does cascading mean? So what cascading essentially does, it combines all the styles that are applicable to an element. So if I take a look at this div, the styles applicable to this div are both of these. So cascading combines both of them and applies those styles. Now, in the process of combining, it may run into conflicts. For example, it is trying to combine these two styles. Now, both of these styles have defined a background. Now, how does CSS know which background to apply? How does it resolve conflicts? So conflict resolution happens using a concept called as specificity. So specificity is a denoter of how specific is your CSS selector. And there's one important thing you need to know. In CSS, you can have three types of selectors. One is the ID selector. One is the class selector, like you are seeing here. And the other one is the element or tag selector. So there are only three kinds of selectors. And in Lightning Web Components, you need not worry about the ID selector because you're anyways not supposed to use IDs because they are replaced with globally unique values. Now, how is specificity defined? So a selector for a tag is least specific, whereas a selector for an ID is most specific. And in VS Code, you can hover over a style and find out the specificity using this handy little feature where this 3-digit number denotes the specificity, where the first number is for ID, second is class, and the third is type. And as you see here, because it is a type selector, the specificity is 001, which is the least specific. Now, even for this, it is the same specificity. Now, when trying to resolve conflicts, the style which is most specific wins. So if the specificity is a lot, that means if you're using a class selector, the styles in the class selector win over the styles in a tag selector. But in this case, it's the same specificity. It's 001 and 001. So in that case, how conflict is resolved is the one that appears last is going to win. That is why this div has gotten the purple color, purple, violet, whatever that is. Now, one common mistake most developers make is in case they want to enforce green color, what they do is they use important. And this is actually not a good practice of using important because it makes it hard to debug. The way you have to enforce styles is to make it more specific. So what I can do here is I can just put in lightning card, which is one of the element here. So I say lightning card, and then I say whatever is a div inside a lightning card, style it this way. Now, if I hover over this, you can see that now the specificity has increased to 2, which means this is going to take precedence. So always try to increase the specificity over using important. So that is a key takeaway, and that is about cascading. So case 1, you've clearly understood why background of blue is applied. Now, in the case of case 2, you have a class of some color, And here you can see that some color is a class that I've defined and the specificity is higher than that of these elements. So it has taken the pink color, I guess. But what you'll notice, I mentioned it is a combination of styles. So padding was anyways defined for the div. And even though I've defined a class, it's still a div element. So the padding still applies. So padding 1rem, both of these have that padding. Now case 3 is your child lightning web component. Now the child lightning web component is also very simple. It's a simple div tag which has some content, and the style corresponding to that is yellow. So obviously your child component is styled in yellow color. But what is important, where shadow DOM is effective, is that even though in my parent component I've said all my divs should have a padding of 1rem, the child component's div did not take that padding. That is because the shadow DOM encapsulates your styles. So even though I've defined a padding in the parent, it's not affecting the styling of whatever is the div I've specified in my child. So that is encapsulation. Now case 4 is slightly different. So in case 3, you'll notice I've just put the web component as a child to lightning card. But what I'm doing here is I've created a div because this styling has to apply. And then I've embedded the child inside this div. So if you look at the output, it's showing just like the first case, it's showing purple with some padding. But even though I've embedded my child component inside the parent div, it still retains all of its styles. So this is the concept of cascading, where it's combination of styles, and during combination, conflicts are resolved with the concept of specificity. Now, my intention of showing all of this to you, by the way, I forgot to mention during the introduction, is that I'm going to give you a very high-level overview, and I'm also planning to confuse you a little bit so that after this session, you go back, do a lot of trial and error, and actually learn this concept. So that is my intention. So until now, you think looking at cascading, you've understood how styles work. But now I'm going to show you the second example, which is inheritance. So if I scroll a little bit down, you'll see the examples for that. But let's look at the code behind it. It's almost the same, again, 4 cases, the same div elements. But this time what I've done is I've broken down the text and put them inside some span elements so that I can style them individually. And if you look at the styles behind it, it's also the same. It has the sum color selector. It has 2 div selectors. But other than background and padding, this time I've given it a text color. So for this div, it is red. For this, it is violet. And there is a new class that I defined for color green. So what am I doing in the first example? Of course, you've understood how the background works. But in the case of text color, so it goes to this div, it tries to find out what color it is. So here it is defined as red. So it shows the sum in red color. And when it comes to the span class new color, because new color is defined as green, it shows in parent in green. But if you come to this word text, which is placed in between span. Now span, I haven't defined the color of span explicitly. But even without that, it has taken the color red. The reason for that is inheritance. Now, there are a few properties like color that inherit the value from the parent in case their value is not defined. So in this case, in parent has taken the color green because I've defined the color green for this class. But for span, I haven't defined any color. Because I haven't defined any color, it looks at its parent to fetch the color. That is the concept of inheritance. And it's important to remember, not all properties are inherited. And how do you know if a property's value is inherited or not? Again, you can hover over a property. You will get the MDN reference link in VS Code. Just click that. And it's going to take you to, hopefully, let me click it. And it's going to take you to the developer.mozilla.org, which has all the documentation for the color. And if you scroll all the way to the bottom a little bit, you can see whether the inherited flag is set to true or not. But in case you want a full listing of all the properties, you can always go to w3.org. And here you can see all the CSS properties along with whether it is inherited or not. That is important to know. Why is it important to know is you will see in just a bit. So case one is red and green, which is cool. In case two, some color, I have given the color violet, and obviously now you know the selector of class takes higher precedence. So case two, instead of red, it shows it in violet color. Case three is the same with your child component. There is no padding applied, there is no color applied. But in case four, whenever I'm placing this component inside a div, and div has a color of red, what you will notice in case four, if you look at the output, you can see that the color of my text inside my child component is now red. It is not black anymore. And why is that? That is actually going against everything that you have learned, that styling doesn't propagate through shadow DOM. There is actually a slight change to that concept. But before looking at that, a quick recap. Cascading is a combination of different styles and prefers specificity to important. And inheritance, some properties inherit their value from their parent, and that is only if they don't have a value that is predefined for them. And here is a flow chart in case you want to take a screenshot and stick it on your desks, whether at home or not. So if a cascaded value is present, that means if I've defined a style for a component, it's going to take precedence. If there is no style found and it's an inherited property, the property value from the parent is going to come into picture. If not, there is no style applied. Now, this is the statement that is true. That is, Shadow DOM prevents cascaded styles, but not inherited styles. That is what has happened here. So if you notice, even in case 4, my child component has just taken the color of the parent component, but it has not taken the padding, because the padding of the child component is still 0. That is because padding is a non-inherited property. So it doesn't cascade down through the shadow DOM. But font color is an inherited property. So inherited properties pass through the shadow DOM and can affect your own components. So this is very important to remember. So in case you are debugging this particular component, let's say the child component, if your QA team raises a bug saying, oh, this is red in color, and you inspect element and see, oh, okay, I haven't defined any red color for this component. It seems to be an LWC bug, or it seems to be a browser issue. You're not supposed to close bugs that way. In case of inherited properties, you also have to look at the parent and see that, oh, I've defined the style in the parent, which is why it is this way. So that was my intention of showing you this example. And understanding cascading and inheritance is really important for you to effectively debug your components. Now, if you're not confused yet, it is good. But if you are confused, my goal is achieved. Go back and look at the documentation carefully, look at all of your components carefully, do a lot of trial and error, and then you'll be able to figure things out. Now, some of you might have a brilliant question. That is, if Shadow DOM prevents cascading, that means other than font color and stuff, padding and all is not affected. Then how am I able to apply SLDS to all of my components? So as you know, you're not importing SLDS into your own components. It's by default supplied by Salesforce. Why is that? Now, that is because on the platform, we are not using the standard Shadow DOM per se. We're actually using a polyfill. And the reason for that is backwards compatibility. Salesforce still supports some browsers like the great Internet Explorer, and it is not capable of rendering Shadow DOM. So we had to build a polyfill for that, and which is what we have nicely named called as synthetic shadow. It almost behaves like Shadow DOM, but it is not actual Shadow DOM. And that is how we were able to get SLDS styles to propagate. And the way we've done that is using scopes. So I can show that to you. So let's say I inspect a particular element. So I'm inspecting the child component. So here I have C child. And this is how I've defined it, C child, and this is child.html, it's just a div tag, and child.css is just a div style. But notice when we have rendered it, we have added an attribute to all of these tags. So the C child has an attribute, the div inside has an attribute, and you'll notice the attribute corresponds to the element, the component name in which this element is present. Now C child is present in cascading parent, so we've added that. Now this div is present in C child, so we've added that. And why have we done this? We have used this attribute to scope your styles. So my background color of yellow, I've just defined a div here, but during runtime, we are appending an attribute to it to mention this div belongs to this particular element only. And all of these styles are added to the top of your page. So this is the HTML and this is the head. And all of your component styles come here. So for example, this is the style for a different component. So with syntactic shadow, what we are doing is we are taking out all the styles from your component, adding them at the global level, and we are using these attributes to scope your styles so that they apply to only your component. But in the case of SLDS, so let's say here I'm using SLDS card. SLDS card is an SLDS style. Why is it propagating and affecting all the components? Because it is not scoped. As you can see, it is just a simple class defined at the top level. So it applies to all the components. So that is one of the important reasons to remember that on the platform, we are mimicking Shadow DOM so that we support all the browsers. And that actually gave us an advantage where we can just use SLDS at the top level and all the styles propagate down. And whatever are the component styles that you have defined, we are scoping them using this attribute. So that's again a concept to remember. Now with this understanding, let's look at two examples. You know, you can import CSS modules from, basically you define a CSS module with reusable styles. So let's say I have a shared CSS file. So I have these three styles that I've defined in one particular module that I want to reuse across all of the Lightning Web components that I create. So what I can do is in a different component, I can just use the keyword import and use the shared CSS styles. This works like, it works the same way like how you would define your own component styles, which means all of your styles are scoped to your component only, which means they don't affect any other component. Any styles inside shared CSS also automatically get that attribute that I've just shown you. Now, the next part is where it gets interesting. Now, in this import CSS with load style, I'm trying to import a third-party CSS. I'm saying it is a third-party CSS, but it is the CSS that I have defined. And I'm importing using this syntax. This is not new. I'm not going to explain it. It's there in the documentation. This is how you load third-party styles. It's just that I'm trying to load these styles on the click of a button. So watch what happens when I click this button. And boom, you can see this style has applied and affected all of the components, not just my component, but it has affected the standard lighting experience. And these colors on the top, everything has gotten screwed up. Why did that happen? Because whenever you import styles using load style, we do not scope it. For all practical purposes, anything that you import with load style are global styles, just like SLDS. It applies to all the elements on the page. Only the styles that you define in your component and the styles that you import using the import syntax. Where was that? Using this syntax. Only those are scoped. And that is one reason to remember, because when you try to import third-party styles, you might run into this issue. So try to do that as less as possible. And to again help you find one common place where you can find all of this information, I've put this slide. So styles imported using load style and page level styles like SLDS are unscoped. So they apply to all the components, not just what you have built. but entire Lightning experience. But the component's own styles and the styles imported using @import are scoped, which means they apply to only your component. And this is because we are using synthetic shadow. And forward-looking statement, we are planning to replace synthetic shadow with native shadow in the near future, at which point in time either Internet Explorer supports Shadow DOM or none of our customers use Internet Explorer anymore. If either of those happen, then we are going to replace synthetic Shadow DOM with native Shadow DOM. So please don't put any hot fixes and fixes that might break whenever we do an upgrade. So finally, coming to CSS custom properties, the reason custom properties is important is, along with inherited properties, custom properties can also propagate through Shadow DOM. And custom properties are nothing but variables in your CSS file. Now, I need not explain to you the use of variables because all of you know it. Why do you use a configurable variable? Why do you use a custom label? Because you define it once, you can use it everywhere. And if you make the change in one place, it affects all the components. So that's exactly what custom properties is for. The syntax is pretty easy. You define a property using the syntax hyphen hyphen and then your name of your property. And then you use the var keyword to use your component, use your custom property. And custom properties can penetrate through Shadow DOM. And I'm going to show you this particular example. And so let's say I have my custom properties container as a component. So inside which, if you look at the CSS file for my component, I've defined a custom property called my subtitle color, which I've initialized to green. And then I'm using this in another class called subtitle. I'm saying color, and I'm using the keyword var, which means it gets the value of this property, and I've defined it. So here I've given the class subtitle, and I've defined the color of the subtitle. And if you look at the output, this is the color of the subtitle is printed in green color, obviously because this div has the color of green. Now I have a child component for this called CSS custom properties. And if you look at the content of CSS custom properties, it's a p tag with astro and cody r, and a span tag with good friends. And this is a style class for that. And you can see for the span, I have not hard-coded the style, rather I have used the same property that my parent component has defined. So my subtitle color from my parent component, I have directly used it in the var keyword of my child component. So I've mentioned this value can propagate down through the Shadow DOM, which is why, let's say if I just embed my component this way, the host, that is the complete component, has defined the color to be green. So what happens? Astro and Cody are good friends is completely shown in green color. Now I can actually overwrite my property value using classes. So let's say for the entire component that is host, it has to be green. But then if I use the class color1, any elements within color1 class have to use red color. And any elements within color2 class have to use blue color. That is how I'm defining it. So here I've defined a div and I've given it a class color1, inside which I've placed the same component. Now, because inside the scope of color1, the subtitle color is red, the output shows good friends in red. Same is the case for color2. In case of color2, it is blue, so it shows it in blue color. So the key takeaway here is that you can use custom properties to influence your child components. And you can easily style child components this way. And if you're the one who is building a child component, let's say I have built the CSS custom properties as a component, but I want to give some amount of configurability to the parent. So I want to say that, okay, use my component, but I'm giving you one ability. So you can define the color of this good friends. And in the documentation for this component, I say you can use my subtitle color in order to send a value to this component in order to style it differently. So that is what I can say. That makes me as the reusable component developer more flexible so that I don't need to take so many change requests. If somebody wants to use this component, but they say, I want to color it differently, I need not create or duplicate that component. I can just use custom properties to style it accordingly. And that is the exact concept behind styling hooks. So in the case of styling hooks, what we have done is we have built these base components. As you know, Salesforce has built these components, but we are allowing you to configure a few things of that component, like the background color, for example. And that is styling hook. It's just that along with the button, that is the reusable component we have built, we've also documented saying that, okay, use this custom property value in order to override the styles of whatever component that we have built. And where will you get to know what are the values that you can override? So you can always go to SLDS website, look at buttons. Let's say if you want to style buttons, and scroll down to the bottom to the styling hooks overview section. At which point you can see that all the styling hooks, if you notice the syntax, actually these are custom properties. All the custom properties that you can use to style base components are listed. So just like the previous example, instead of using my own custom property, I have used the custom property defined by Salesforce. So for host, that means for all the lightning buttons, it has to be orange. But for the lightning buttons inside color 1, it has to be black. That is what is happening here. So this button will be shown in orange, and the button inside color 1 will be shown in black. And if you are not believing me, then look at the output. It's orange and black. It's as simple as that. So that is the power of custom properties. And you know, custom properties are used literally everywhere in Salesforce. So for example, if you go to your profile and you're trying to change the display density settings from comfy to compact, which actually reduces the padding between elements. How did we do that? We've used custom properties in all of these standard styles. And at one place, we have defined the custom property value called, let's say, 1.5 rem. And the moment you change the display density, we just change that property value from 1.5 to 1. And since that property value is used across all of the different components, the display density is adjusted accordingly without me having to explicitly update so many components. So custom properties is important and widely used. And when it comes to styling hooks, please don't override standard styles because we have given you styling hooks. And the reason we ask you to avoid overriding standard styles is these are subject to change. You never know how we change base component internals. Maybe we use a different style class tomorrow. So your customizations will break. So please only use styling hooks. And this is currently in beta. So we are looking for feedback in case you are planning to style a base component and styling hooks are not available for those. Please submit it using this link and we will take a look at it. The more number of requests we get for a base component, the higher on our priority list it is going to be. And global styling hooks are coming soon. So what you have realized is I'm able to currently use these styling hooks to only style custom components. But what if you want to style standard components? Like, let's say you want to style, I don't know, there is no standard component here, but let's say you wanted to style the chatter component. So we are going to come up with global styling hooks in the future. This is forward looking. So stay tuned for more information. And where are the other places where you can use custom properties is SLDS design tokens. So SLDS also exposes its own design tokens in the form of, let's say, the color that we use across Lightning Experience. It's not black, it's slightly grayish. And how do you get access to that color? It's using this SLDS design token. And how do you use this design token in your LWC? Just say var -LWC token name. And these SLDS styles are going to be applied there. So you will realize that custom properties are used in so many places, including Aura design tokens. So let's say you have an Aura token. This is how you use it in Aura. You say token and token name. But you can use the same Aura token in LWC also, using the same custom property syntax. So --C, which is the namespace of the token, and the token name. So that is almost about it. Just one final quick tip. You can actually use custom properties to send your value from JavaScript to CSS. So let me show you an example here. So I have a component, JS properties in CSS, which is the background is black and the text is white. Now, if I go to the app builder, I have exposed the colors to the app builder. So if I change this from black to red, it's getting changed. Now, one way I can do this is to, of course, use DOM manipulation, but it's not really a best practice to manipulate DOM using JavaScript. So what I'm doing here, again, I've used CSS custom properties. So instead of hard coding the value of black and white, I've used custom properties. And from my JavaScript, I'm querying whatever is the style class, which you can always do. But instead of setting the style of a component, I'm actually setting the property value. So I'm saying .container.style.set property and the property name and the property value. So this way, I'm not manipulating the DOM, but I'm actually setting the style property of the component. And as you know, we can use the CSS custom property in any class. That way, you maintain complete configurability. And in case you want to apply the same style to a new element, you need not again write new JavaScript code to query that element and apply that style. So custom properties is a lot, and I can go on talking about this for half an hour more, but I am not going to. But like I mentioned, this is just a peek into what you can do with CSS, the power of CSS, and what all you need to know in order to style your component correctly. And to quickly summarize, style inheritance is different from cascading. I think you've got that by now. And shadow DOM only prevents cascading, but not inheritance. And be careful. You need to know whether your style is being scoped or not. If your style is unscoped, you have seen my entire lighting experience is now in orange color. And custom properties propagate through shadow DOM. I have spoken about custom properties for the past 10 minutes, so you know it has a lot of capability. And of course, you can use styling hooks instead of overriding standard styles. And in order to reuse your CSS custom properties across different components, you can create a shared module with all the CSS custom properties, just like you would create Aura design tokens. And in case you want to use a token across both LWC and Aura, create it as an Aura design token, because that can be used both in Aura and LWC. So these are a few things. I know it's been a really quick introduction. It's not a deep dive, but you can definitely check out a deep dive on the same topics. You will be able to find it on our YouTube channel, the Salesforce Developers YouTube channel. It's just an hour and 15 minutes long. So that's a really deep dive into all of these concepts. So I hope this session was useful. And in case you want to try the examples that I have shown you, this is the repo. Clone this repo, install it in your Scratch org. Feel free to try out, feel free to experiment, and finally get a good understanding of how styling works. Because if you spend the effort now, you don't have to spend any effort in debugging all of your styles. So with that, I hope you've had a wonderful time in my session, and I hope you have a wonderful time in London's Calling. And I also want to thank all of our sponsors without whom this event would not have happened. And with that, thank you, and get in touch with me on my Twitter handle in case you have further questions. And bye-bye.